explain it to them later, would you? All right. So we're gonna continue to work through these calculators, and the hard thing is not everyone has one. It is an expectation that you do get one of these calculators, because they won't always be provided. Okay, it's not Cherry Creek High School's job to get you a calculator. So some places I would definitely recommend that you take a look to find these. And this is going to sound goofy, but pawn shops. Mm-hmm. Like if you walk into a pawn shop, I'm serious, you'd probably pick up one of these for like $6.
How much could I get for this?
With the pawn shop selling for $6, they'd probably give you 2. Even though it's a $100 calculator.
$2 is $2.
Yeah, I got you. So, or if you get on eBay or any of those, even Amazon has used ones that you can get. There's a lot of them out there. So the excuse of, oh, I can't afford one. Really? You can't afford having somebody go, my mom will never take me. Really? Then your mom sucks as a parent if they'll never take you anywhere. So, just it's funny when you get all the excuses in the world. Oh, I can never do this. I'm just victimized to my house. And you're like, no, you're not. You're making excuses that you can't. And I know that you can. All right, so we're going to walk through these pretty slowly. Okay? Again, these are all things that we're slowly going to transition you into learning. Of course, you can do this by hand, but doing it by hand is a lot harder than doing it on the calculator. So this says a statistics student wondered if she could predict the number of people that would be at a neighborhood pool based on how warm it was during the day. You guys remember when the pool was open rather than when it was freezing cold? And she tracked the attendance for several days and she obtained the following results. Okay, so first thing you have to determine, is the temperature here going to be the x-axis? Or is it going to be the y-axis? Or is the people going to be the x-axis? So temperature, as the temperature goes up, more people at the pool? Make sense? Okay. So I want to go ahead and plug this information into my calculator. So everyone who has a calculator, you ready?
Yes. How do we do it?
Well, that's what I'm going to walk you through. Okay, so eyes up here. If you're not sure how to do it, I will go slow. I'm going slow for a reason. Don't assume you know how to do it. Okay? And that's fine. So ready? So I'm going to get into my calculator, and this is my first thing I'm going to do. Second, you still with me? Pay attention. Pay attention. Second, plus. Still with me? Number 7, reset. Number 1, all RAM, and then reset. Okay, because most of you are using a calculator that's from our class. By us doing this, it clears out any of the goofy things. Got it? Make sense? All right. Everyone feel comfortable with this?
Take it.
She doesn't like you doing it?
No, she doesn't like it.
Okay.
Because she wants to do the work.
Okay. Is it all clear?
Yeah.
Okay, good.
Yeah, because I cleared it.
Thank you. All right. Ready now?
Yes.
All right, so I'm going to do this. Second, still with me? Y equals, hit number 1, and then hit enter. You're done there. So second, Y equals, number 1, enter. Good? So by us doing this, it will allow us to plot our data. Okay? Find the stat key and hit that. I have it highlighted in red for you. Now we're going to edit some data. You okay?
Yes. Yeah.
So I'm going to go number 1. And notice here's list 1 and list 2. So all the way down list 1, we're going to plot the temperature. So I have 80. And you have the same information on the front of your sheet. So let's say you make a mistake like I just made. I just made a mistake, yes? I didn't give you the notes? Oh, I'm so sorry. I'm like, I was excited y'all had calculators and we were able to reset the calculators. Sixth period? All right. I don't have an on button. Turn your calculator over. It says no. Okay, turn it upside down. Oh, it says on now. Okay.
Stop it.
No.
I'm so sorry. I meant to hand these out to you.
Thank you.
So I am at the bottom of the first page. And I'm going to start plotting this data. Okay? And what you might notice when you're looking at the data is you notice I might have just made an error on this piece of data right here. Agree?
Yes.
Does everyone agree? 80, 82, and then I put 93 rather than 83. So if I make an error, I'm just going to do this. I'm going to arrow back up to it and type in what it needs to be corrected. Okay? 84, 85. 86, 87. 88, 89. 91, 92. I think I have all my information in there, right? And then the arrow keys are what you're going to use to move around. Double check your data. So with the 80, I have 121. For 82, I have 120. And again, you're probably looking at the sheet, able to do it just fine.
Why is there no 90?
There just wasn't a recognized temperature. 83, 126. 84, 127. 85, 124. 86, 130. 87, 133. 88, 133. 89, 138.
Give it to him.
Bless you.
Thanks, everybody.
120. 120. All right. Yes, sir.
Okay. Now, a big spot where people will make errors on this is they didn't type their data incorrectly, or let's say they had 15 pieces of data and one line had 15 pieces of data and one only had 14 pieces of data. That's called the dimensional mismatch. Okay? Does anyone need more time on plotting our data? Where'd you stuck? Do you want to hit? So use the arrow to change it. Go to the arrows. Arrows right there. Okay, and what do you want? Okay, so just type in 145. So why do you have extras? See that row is there. And this one is down. Alright. So we're going to go right across. Do me a favor. Ready? So look here, you have 80 and 121, correct? Yeah. What's the next one? 82 and 120. Good. 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 Yeah. Good. 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 Yes. Okay. 94, 142. Okay. 95, 138. Okay. 96. But now yourself. Okay. Everyone have all their data in there? So we turned the stat plot on originally. That was where we went second y equals, and then we turned the stat plot on. So here's a great thing. If I hit zoom right now, and being we're plugging in stats, so zoom number 9, it's going to give you the data that looks like that.
How do we know what the interval goes by? There's like little marks at the bottom. How do we know those intervals are?
I'll show you that in a second. Okay, one I will tell you they're even amounts, but they might count by 1s, 10s, 5s, 7s. We don't know, but we'll get there. Because what we did, Oliver, is being that we zoom fit, that allowed us to see in our window our data. Okay.
Why doesn't the calculator automatically do that?
Go work for TI. Tell them to figure it out. Thanks, man. Make my job easier, huh?
Yeah.
just start talking into it. Put in 3, 7, 4, 2, 9, 6.
Awesome.
It's a matter of time. All right, so now here's the tough thing. We're looking at data. Does it look like this has a certain pattern to it that comes up this way for the most part?
Yeah.
Now, again, we're not looking at the most real life scenario of things. In the real world, if we were going to collect this kind of data, we would have thousands and thousands of data points to plot. Okay? But we don't have time to plug thousands of data points. Ethan, what you doing?
Ran into a little trouble.
Okay. All right. So there's one more thing that we're going to turn on the calculator. Okay? You ready to follow me? Okay. I'm going to hit second. Still with me?
Okay.
Plus. Nope. I just went to the wrong place. Hit second one more time. Hit catalog. I'm sorry. I went to the wrong place. Second catalog is at 0.
Where's catalog?
0. Second 0.
Abs?
Wait, is this on the internet?
Abs.
Okay? We good? Everyone at this list? We're going to do something we're going to call diagnostics. So I'm going to hit this x to the minus 1, which is the letter D. Is that okay? Notice A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U.
Now I know my ABCs. Next time, what you sing with me?
Yes. And I'm going to move my arrow down. Oops. Move my arrow down to diagnostics. And I just accidentally bumped it with my finger, so I got to go a little further. All right. You see that? Find the button that says diagnostics on. It's under second catalog, which is the second of 0. And then go down to diagnostics on. And once you get there, just pause for a second.
Wait, I don't have diagnostics. Scroll down.
A, B, C, D. And then you should
I figured that out.
Everyone there yet? Anyone need more time?
Wait,
Find
hold
it.
on. I'm still trying to find it. What is it? Diagnostic?
Diagnostic on. What letter are you on?
Sorry, this would be a lot quicker if I.
Find it? Everyone find it? Anyone still lost? So what I'm going to do is I'm going to hit enter and then hit enter one more time. So it's going to look like that on my screen now. So you hit diagnostic on, so you hit enter, enter. Oh! Ah!
I put
Everyone find it? We good? Yay? Can I move on? All right, so now we're ready to get the calculator to do the work for us, okay? So I'm going to go stat. It's highlighted in red on the board if you need to find it. Ooh. Then I'm going to use my arrow, and I'm going to arrow over to calculate. You with me so far?
Yes.
And then I want to do the linear regression. It's number 4. So you type number 4, and you arrow down to calculate. And that right there, guys and girls, is my equation. But you'll notice there's an r squared and an r value. Okay? So this linear equation, I have a slope of 1.55. So y equals 1.55x minus 3.95. And then I'm not too worried about the r squared value. I'm worried about the r value. The r value looks like a 94.55% on a test. Is that good?
No.
If you got a 94% on a test, wouldn't you be like, dude, sweet?
My mom would kill me.
Well, hey, sorry. Being yours has been transposed for a while at 49%. I'm just kidding. All right. So this means this r value here, the closer this r value is to +1 or to -1, the better your data is. Yeah.
Oh no, I'm just raising that.
Okay. All right. Ready? Yeah.
How can your data be better than other data?
It just means that the line that we're on, the calculator feels very confident that's the correct line that it has selected with our data. That's all it is. Okay, and Oliver, actually how it works is this. So I'm going to take a side note real quick for you. Okay, so this is what the R value is. It's this distance plus this distance plus this distance plus this distance, this one, this one, this one, this one, and this one. If I take those vertical distances and I add up what those distances are, because that would be my point, this would be my line of best fit, and then I divide it by how many points I have, it's going to give me an average, and that's what we're doing. So the closer it is to 1, the better, or the closer it is to -1. It'd be -1 if the line went like that. That's a negative slope line. +1 if it's like that. That's all it's doing. So it's just taking the average of the distance from the points from the line. That's the fundamentals of it. Okay? All right. So we're ready to plot this. We're ready to plot this on our calculator. Hit y equals. You with me? What happened? Oh, you're okay. You should be fine. Hit y equals. It should be still stored.
What'd you do?
All right, still with me?
No.
Why?
Because
You told me to graph it.
Okay,
He didn't tell you to.
Ready?
He said press y equals.
so hit y equals. Everyone here?
Yes.
Does everybody have this darkened right up here?
Thank you.
Yeah? No? Who said no?
No, I meant I'm not giving him the calculator.
Okay, ready? Shh. Find the vars button. I made it red. Move down to statistics, which is number 5. And then arrow over to equation. You there? Hit number 1. And it's going to store that information there. And then once it's stored there, hit graph. And there's your line of best fit.
Okay.
Wait, I thought your line of best fit had to be completely straight.
That's a pretty straight line there, Gypsy.
Is it?
Statistics number 5.
I mean, for a
Mine is not
calculator.
straight.
For a calculator, it's pretty straight. What are you doing?
Going back.
So you're messing it up.
What's what you're doing?
No, the line is complete.
Bro.
I just forgot to do the line stuff. What's bumpy? Our line's bumpy? Okay, so a couple things about this. These screens on these calculators, they aren't HD. In fact, the little tiny pixels inside of here, the little tiny pixels that make up the whole graph, which there's probably a couple thousand pixels in here, TI, for some odd reason, has decided they want to make all of their little tiny pixels rectangles, not squares. So that's why we sometimes won't have the most smooth. That's why. So it's an operating system error. For the most part, this is a straight line, but it's just because TI has made their pixels rectangles rather than squares. It won't be a smooth line.
How do you order an LCD that has rectangular pixels?
TI had the corner on the market on pixels originally. And that's what their patent was, and so they decided to stick with it because they saw the patent on it. What good is it other than making a straight line kind of jagged? I don't know. All right, so now we have this line of best fit, which is great. So I'm going to go back to the notes. I'm going back to our notes. Okay. All right. So a few things. I'm going to get rid of this. Step 1, make sure you write these values down.
This is so cool.
Whoa, hey buddy. Stop. Where'd he go? Why did this go there? Okay.
What?
There we go. Alright. So step 1, you have X values, Y values. Step 2, go to lists. Step 3, clear the lists. Step 4, L1 is X values, L2 are Y values, and then get the regression equation. This is all stuff that we just did. Okay. Is that okay? So again, this calculator is a pretty cool tool that works for you in math. Okay. Are you experts on using it now that we've done it for 3/4 of a day? No. I know that. So let's move on. So it says, in order to calculate the line of best fit, you determine your x values and y values. That seems good. You hit the stat button, then you hit the edit button. This is the step-by-step order on that calculator. Clear all your data. So I want to go back to our calculator, and I want to start clearing data. Ready? Clear. Where's the clear button on this calculator?
Right here, under the arrows.
Under the arrows, and it says the word
Clear.
good. So if you're going to do this, so you could go into Stat, Edit, arrow up, hit clear, down arrow, there goes that. Arrow up, hit clear, down arrow, that's gone. Okay? So that's what they were saying to do on the calculator. Then enter your x values into L1, your y values into L2. L1 is x, L2 is y. And then find the equation of line of best fit. So one thing that stands in the way a lot of times is people go, well, I already have something in y equals. Well, that's my old equation, isn't it? Clear that, it's gone. So now the calculator is ready to be used over and over. If you learn how to clear the data and you learn how to clear what you put in there, that's awesome. Okay? Does anyone need to walk me through that? Let's clear one more time. If you've already done it, fantastic. Hit Stat, hit Edit, arrow up, and then, so that's highlighted, hit Clear, and then down arrow. And then move her to L2, up to the top, hit Clear, and then down arrow. It'll get rid of your lists. And then if you hit Y equals, if you have anything in Y equals, just hit Clear again. Notice that Clear button does some neat stuff. It gets rid of stuff. Okay, can I move on? All right. So we have some correlations here that are great. So I'm going to say that this has a correlation of 1. This has a correlation of -1. So a correlation of 1 means I have a really good line of best fit and I have a positive slope. A correlation of -1 means I have really good data that fits on my line and I have a negative slope. That's all it means. So this means I have a positive slope. This means I have a negative slope. Okay? These values are close to 1. So like this might be about 0.96. This one over here would be like -0.96. This is a little bit weaker, so this might be like 0.65. This might be like -0.65. And this one right here, this is like, I don't know, 0.50. This is just like gunshot blast. There's no correlation. You don't have any pattern to this. Okay, so that's where your R value on your calculator works for you, okay? Everyone still with me? May I move on? So strong positive correlation means you have a positive slope. Data falls into a line. Strong negative means you'd have a negative slope and your data is in a line. The closer you are to +1, the better your data. The closer you are to -1, also the better your data. The closer you are to 0, really bad data. Okay? So we just talked about this. We had this. Will someone do me a favor? Because I cleared mine out. And let me walk through this real quick. Somebody tell me what your list 1 is. Go down. Look on the worksheet. Just tell me what.
80.
Oh, I will.
80, go ahead.
82.
82, go ahead.
83.
83, go ahead.
84.
84, go ahead.
85.
85, go ahead.
86.
86, go ahead.
87.
87, go ahead.
88.
88, go ahead.
89.
89, go ahead.
91.
91, go ahead.
92.
92, go ahead.
93.
93, go ahead.
94.
94, go ahead.
95.
95, oh, hang on. 95, go ahead.
96.
And 96. All right? Cool. Enter. All right, go up to list 2. With 80, I have what number?
121.
With 82, I have what?
120.
With 83, I have what?
126.
With 84, I have what?
127.
Okay. 85?
125. 124.
86?
130. 133. 133. 138. 136. 139. 145. 142. 138. And 145.
Thank you. All right, stat, edit, no, stat, calculate, 4, enter. All right, so I have y equals 1.55x minus 3.95, and I have an r value of 0.9456. Okay, good. So with that information, I'm going to go back to this. What is the equation of the line of best fit? Well, I just found it on the calculator. I found it to be y equals 1.55x minus 3.95. Okay? So what does the slope mean in the context of this problem? There's 1.55 more people that come to the pool for each degree we increase. Can you have really 1.55 people?
No.
No. So you didn't have someone showed up in a wheelchair missing arms and legs, right? So,
Why would they
So-
go to the pool then?
because maybe their name is Bob and they just float and they call him Bob.
Yeah, they could dip.
Wow.
All right. So what does the slope mean in the context of this problem? You get 1.55 more people to the pool each degree the temperature goes up. Pretty simple. What does the y-intercept mean in the context of this problem? So that's the y-intercept. Do you really think I'm going to have negative 3.95 people that show up to the pool?
No, sir.
No. But if it was 0 degrees outside, you'd have negative people at the pool. It's kind of silly, right? And then what does the correlation mean in this problem? Well, being we said is 0.9456. This means we have a strong positive correlation. Strong positive. Okay, is my slope positive? Yeah, it's 1.55. My data fits about 95% accurate on my line of best fit. Okay. So residuals is the difference from what we observed and the equation predicted. The chart below shows the high temperature each week for 36 consecutive weeks. Is y equals 2x plus 40 a good model to use for the data or bad? I have the hiccups, excuse me. Good. All right. So they want us to use this. So they collect the data. We're asking, is this a good equation to use for our data? And let's see this one more time. Residuals, errors, the difference from what we observed from what we predicted. That's my next slide. Okay. So this is my observed information. This is the one that goes with it. All right, so let's fill out the rest of this graph. If I take 1 and plug it in, 2 times 1 is 2 plus 40, I get 42. If I subtract these, I get 4. Is that okay? If I take 2 and plug it in, 2 times 2 is 4. 4 plus that is going to be 44. Subtract those, so I get 3. So my residuals are right here. My observed versus my actual. Okay? Let's take 3, plug it in. 2 times 3 is 6. 6 added to 40 is 46. Subtract those, I get 2. Plug 4 in. 2 times 4 is 8, plus 4 is 48. Subtract those, I get 1. Plug 5 in, that's 10, that's 50. My residual there is 0. Making sense so far? And then if I take 6 and plug it in, that's 12. 12, that's going to be 52. If I subtract those, I get negative 1. I think I'm done, almost. Yep. Does that make sense? So I had observed data, and then they said, here's your equation that goes with it. And so we wanted to find the residual. So the residual 4, 3, 2, 1, 0, negative 1. Okay, data seems pretty close. That's good to go. Last slide. The waiter decides to see if he can predict his average tip based on the cost of a meal he served. For the next 5 single diners, he records the meal price and the tip to them. The results are shown below. Okay, so let's find the line of best fit on this. Ready? Let's find the line of best fit. Going back to the calculator. Y equals. There's nothing there. Great. I want to plot my data. Stat, edit. How do I clear my data?
Press the clear button.
If I just hit clear right now,
And then
No,
I have
just
to
spam
go-
it.
go up and down. So go up to the top of it, clear, then down. Now I'm going to plot this information. So I have 4.75, 6.84, 12.52, 20.42, and 8.97. And then you got a 50-cent tip here. Whoops, 0.50 or just 0.5. 90-cent tip here, so 0.9. $1.50 here, so 1.5. $3 here, and $1 here. Okay, so this is the data based off of the meal cost and whatever the tip was given. Let's find the equation of the line of best fit. So the line of best fit, how did I find the line of best fit? I have my data. I can go zoom stat. I can go zoom stat, zoom number 9. There's what my data looks like. How do I find my line of best fit? Where was it at? Stat, what's next? I want to calculate my line of best fit. What's next? Calculate. And I want to find a linear regression, which is which number? We'll go with 4. You want this one? This one's the same thing. We blame the French for having this one go in there. They do their slope backwards than ours. So do number 4. Your answer's still the same, just as long as you realize what the slope is. So I get this. All right, so I get an equation of y equals 0.157x minus 0.299 with an R value of 9911. That's pretty good R value. Yay. All right, so let's do the line of best fit. I think we can answer the rest of this with, so use my calculator, line of best fit, so I get y equals 0.157x minus 0.299. Interpret the slope. Gets about 16 cents more each dollar spent. 16% tip. Okay. What is the y-intercept in the context of this problem? Negative that, so if he has a customer that orders nothing, he's losing money. He's losing about 30 cents on that customer. I don't know how, I'm just saying it with the data. Our coefficient is 0.991, so this is strong positive. Then it says, hey, approximate the tip if it was $10. Okay, I'm going to take 10, plug it in right there, which is going to give me 1.57 minus 0.299. You have a calculator there. So that's about 1.57 minus 0.30. Okay, because 0.299 rounded to the nearest cent. So it looks like he's going to get a $1.27 tip. Okay. Is it good money? I don't know. I've waited tables. I'll tell you what. There's times that you have people that give some of the best tips in the world. And then there's times where people stiff you. I actually worked at a restaurant where the owner used to, if the people would stiff a person on a tip, the owner would walk out and ask the customers, is there anything wrong with the meal? And they said no. And they said, well, you know you need to tip. And I've watched the owner say this. If you don't tip, you don't come to our company ever. And told the people to leave. It was a very successful restaurant.
What restaurant was it?
It was a place called Nello's Pizza. It was a Chicago-style pizzeria.
Hey, let's go.
And it had some wonderful deep dish pizza. All right, so your homework for tonight is going to be page 113, 114. So, page 113, 114, 115. Do not, watch this, do not do more than 20 minutes on it tonight. Okay, if you've gotten to 20 minutes working on it and you say, hey, I give you an honest 20 minutes, great. That's all I expect of you, okay? I have one more calculator out there. Who has it?
No, you're that.